Right, we are live. Welcome everybody to the node.js security meeting, last one of October. Um, Before I start, does anybody have any announcement? I don't think so. So, as usual, I will ask you to include your name to the minutes. I'm sending it on the chat. Uh, if Zoom let me to do that. For some reason, okay, now I sent in the chat. Thank you, Michael. Um, So as usual, we go to the vulnerability review, open SSF scorecard, and then we discuss about the tasks. So on the vulnerability review, I remember that we received some issues about V8 because recently V8 uh, published some CVEs that impacts Chromium and Chrome itself on V8. And they are asking if it affects Node.js. So in our threat model, usually we trust um, on on the code that is being run. So most of V8 vulnerabilities requires that or assumes that the runtime or the user don't trust the code. But we in our threat model we specifically say that we trust on the code being run. So please don't run untrusted code on that. So I included a label to the first issue that don't fall in our threat model. And the second one, I'm waiting for the V18 to assess its impact, but I will need to ping them again. Assessment as right. Okay. I've just pinged V8 on that. Anything else to add, Michael?
No, otherwise the automation hasn't reported anything new.
Yeah.
Um, and I see that one, yeah, like you've already gone through the discussion where it's like based on our security model, they're not actually vulnerability. So it's good to document that for people who are interested.
Okay. Um, the next one is the OpenSSF scorecard monitor. Just take a look. Just took a look on that, and nothing has changed. We have just one increase on LLHTTP, but it might be just because of a recent pull request that got merged. So all good so far. Uh, and that ends our prior work. So now we can go to the Node.js namespace and talk about the pull request number 54364, which is add WDAC integration on Windows. And I would like to invite Robert to share share a summary about that, and then we can discuss. And Lee Home, sorry.
Yeah. So a little while back, we kind of discussed the desire to get code integrity as a defense and depth feature in a node, and we came upon an agreement that we feel like it's a valuable feature, but the node policies was historically how this was implemented in node. But with the removal of the policy feature, that kind of removed a bit of the code integrity work. So we wanted to go ahead and add in code integrity this time with a bit more kind of like native support from the operating system. So system administrators could have kind of like a one-stop shop to administer code integrity policies on their machine. And basically, this is done on Windows through WDAC, Windows Defender Application Control. And WDAC provides a couple APIs that interpreters can call to ask the operating system questions about kind of the code integrity policy on the machine and whether or not a file that an interpreter wants to execute has been modified from the values that has been modified from kind of the original value that the system administrator kind of specified to the machine. So I went ahead and basically in the places that I saw calls to the policy integrity assertions, I replaced those with calls to the WDAC APIs to ask the system, hey, does the basically among many other questions, has this file been tampered with from the original value? And the system will reply yes or no. And if it has, and the system is a node is enforcing code integrity mode, then an error will be thrown and execution will be stopped. So basically the flow is on a secure work system or high risk machine, there will be a code integrity policy installed. And in it, in a settings configuration area, the system administrator will configure a setting that tells Node, hey, we're in a restricted mode. Node, please start enforcing code integrity. And then on initialization, Node will ask the system, hey, should I start enforcing code integrity? It'll query the operating system for that policy setting. And then if that setting's set, then whenever, I think I added it to one of the loaders, whenever the loader tries to read a file off a disk, it will first verify the integrity of the file and ask the operating system, hey, am I allowed to execute this? So the implementation is in that pull request. That's a high level overview. If you have any questions on specifics about it, I'd be happy to answer, or any other high level questions, design decisions, any further questions you might have on WDAC, I'd be happy to answer.
Okay, I'm looking to the code, and basically it asks is allowed to execute to file, and what does it rely on file system permissions, right? Like so in order to return true on that specific function, the user needs to give permission or specify a set of permissions to a specific folder and a file. Is that correct?
Not entirely. I'm not sure what you mean by the permissions given. Basically, the integrity is verified using a digital signature and hash-based integrity verification. Basically, on the system, are you familiar with a Windows catalog file?
I'm not familiar with Windows at all.
Okay, that's fine. It's basically a list of hashes. It's a file that contains a list of hashes, and then that file itself is signed. So basically, to verify the signature, the application publisher would create a catalog file with basically they'd run a PowerShell command, new file catalog on kind of the release build of their application, which will then hash every file in there, add it to the catalog, and then they'd sign it. So the catalog would have to move as part of the application. So when it's distributed, the system administrator would put the node application on the machine and would take the associated catalog file and install it on the machine the application is intended to run on. And then once that catalog is installed, this API knows to consult all the catalogs that are installed on the machine to see if the appropriate hash for that file is on the machine.
So it does require a prior work before running the application itself, right? But what if during the runtime, the user creates a user and attempts to execute it?
I'm sorry. So could you give me a bit more detail on that, Coach?
Okay.
So so let's say I have my application, my Node application on a machine. What's and I'm a malicious user.
Okay. Um, if I'm understanding it correctly, I am a developer. And I'm publishing this application in production. So before the setup is, okay, I need to create this catalog of files. So I need to specify exactly which files I expect to run on this binary, and this binary read these specific file paths. If the integrity doesn't match, the code will throw. That's the happy path, right?
Exactly.
But imagine that some applications requires to create files using the file system API from node.js during runtime. So I create a JavaScript file during runtime.
Yeah.
And I try to evolve that or spawn a process that will read that file or execute that file. These would bypass the policy permission by spawning a second Node.js process, or
I
because
think if I understand it, like your policy for the machine could say you can only run things that are signed. So if you dynamically wrote a file and it doesn't have an entry which has a signature for it, it's not going to let you run it.
Yes, but I expect that this flag will be opt-in, right? If I don't opt in, it won't check for policy
But it's
integrity.
configured. Like, I think it's that, like, if I understand it, all the configuration has nothing to do with Node. It's all Windows based, right? So like for Windows, they've got the feature basically lets you say, unless the signature checks, don't run anything. And so like that was going to be one of my questions here, at least, is like in the code right now, there's no flag or there's nothing in Node that turns it on, which like typically we start by having things that like require an experimental opt-in flag or something like that.
Yes.
So that, but in the, you know, in the fullness of time, say when it's just on by default and basically it's checked based on whether or not the system configuration is there, like it's something like, and that's, and I'm also assuming that like only the admin can set up that configuration. So, you know, I
That's
think it sounds to me like it would be safe in the sense of it won't let you run anything that hasn't been approved based on whatever policy was set up for the Windows machine.
But it does require to pass a flag. That's my point, right?
Right now,
no.
no.
No. I mean, if we want to merge that, it will require to have a flag, I guess.
That would be part of the like the discussion of
The
like how
experimental flag, because we can't just enable that by default. Otherwise, it might break users.
right. So that was my first question, is like I don't see any flag which, you know, turns it on.
Okay, yeah. Yeah, I understood that this is just for example, or to evaluate these pull requests easily.
So there is a flag. It's not implemented in Node. The every policy in Windows is opt-in, and so as an admin, like all you know, minus if there's some like bugs in the Node implementation, but it is first looking into the Windows settings, and if those aren't enabled, then none of this code path is gonna trigger. So everything's opt-in. There's no need for an experimental pass because you can always opt out by just turning off the node feature in the code integrity policies.
Yeah,
Okay.
so the absence of the setting is interpreted as the setting is off. So we wouldn't verify files on probably like 99+% of Windows machines this is running on.
And is there a node specific configuration entry?
Yeah, so the WDAC, the policy system provides basically an arbitrary key value pair dictionary within the policies. And I just went ahead and kind of declared one for Node, which would just be I forgot the exact name spacing on it, but I think it's just node.js, enable code integrity enforcement. And
Okay, so nobody will have that turned on today, like in terms of
yes,
breaking people or whatever.
that's correct.
And what security guarantees do we expect from this feature? For instance, I'm looking to the code and I'm seeing that we are adding some checks on the common JS loader, right?
Mhm.
However, that can be easily patched by a monkey patch, right? If someone monkey patch that specific function, or the call itself, which is the one of the reasons that why we removed the experimental policy. There are many ways to bypass that because it's a JavaScript checks. So we
Mhm.
can basically monkey patch and bypass some of its guarantees. How do we expect to have that guarantee, or we are seeing that as a seat belt
I
instead of a
think,
security feature?
yeah, I think this should be viewed as an extra layer of defense,
Okay.
but I will say, like, this is probably like with a lot of things, this is probably going to be something that we iterate on, find potentially more vulnerabilities in the future, figure out ways to mitigate them as we move on. And like, this is something that if this is a problem with my implementation with it, this is something I'd be happy to continue to maintain and plug these holes as they arise.
Yeah, my question is just because if depending on the view of this feature,
Mhm.
if we treat those bypass as a vulnerability and we want to avoid them as much as possible, it means that we are increasing the amount of maintainability and the extension that this code
Mhm.
will run. So it means, okay, we will receive some reports, we will need to
Mhm.
open several requests, and it will be very hard to maintain. That was what happened to the policy one.
Mhm.
And I
Yeah,
think
sorry,
go
go
ahead.
ahead.
I think we've seen that in a few places. So I think like in the permission model one, we've ended up with some documentation, like in the documentation, making it very clear that like this is a seatbelt. There in the face of malicious code, it won't necessarily protect you because because of the monkey patching and all that. So I think like we need to make sure in the documentation it makes it very clear like this is seen as a seatbelt. We know it can be circumvented by malicious code. We might even want to say like, and we don't consider that those circumstances to be like vulnerabilities, just like additional feature requests. Like maybe we can sort of cast it in that kind of wording. And the so I think that that like that's definitely something that we need to have in the wording. And I don't know, Raphael, if you've seen like we can still borrow some wording from the permission model to help us on that front.
Yeah, we can for sure. I'm just more worried about the expectations of this feature than really giving users a warning about ways of bypassing it. Because since if we from scratch decide, okay, we impose that limitation if a user don't run malicious code. So that is a guarantee that we can for sure do, because we don't need to deal with a specific edge case where malicious code will monkey patch or call a specific function differently. So I think that's something that we could do for sure. Um, and just to uh, go back a bit on the
Mhm.
subject. Um, we were discussing about how this feature is enabled. So you told that if there is a catalog or if there are some flag on the system, Node.js will interpret that as on and will check by default, right?
Correct.
Okay, so that basically uh, uh, fixes my edge case of spawning a second process of Node.js. Okay. And are we expecting to implement that for other environments, or do you believe that enable it only on Windows for this experimental phase, it's okay?
So at the moment, yes, it's only implemented on Windows, and kind of that's the area that I have the most expertise in with the code integrity enforcement. But there are drives. So my understanding is at the moment, the Linuxes don't provide a similar API that's the equivalent of this. But there are proposals in the pipeline that have yet to be merged upstream and accepted. One of those proposals is it's changed its name and form a couple of times, but I know it as OME exec, but it's basically it's an API where on Linux you can ask the system the same question. Hey, I want to execute a script file. Is the operating system going to allow me to do this? I'm tracking those changes. They're being done by someone on one of our partner teams. So if those changes land, slash when those changes land on Linux, I can work with them to kind of integrate a similar behavior on in Node if that's what you all want. As for Darwin or Mac, I'm unsure. I'll admit, I'm not terribly familiar with kind of what APIs they present for that, but would be happy to work alongside people to help kind of get feature parity across different platforms. But to answer your question succinctly, at the moment, Windows is the only one that I know of and have expertise
That
in.
implements its support.
Is there anybody from Red Hat involved in that Linux effort? Do you know?
Lee, I'm not sure. Lee, do you know?
No, I'm not sure specifically who's involved. It's been going on for actually quite a few years. It's been through like 4 major iterations, and so if there are specific folks you're interested in getting involved, or we could absolutely.
I'm more like there is somebody, they'd be like a resource I could go talk to and see like how interested they are in getting it into Node or not. But anyway, I like that's just if you said like, oh yeah, I know this person, I would go and talk to them. But I don't think that really that's I think we have the answer today. It would be Windows only. I think that's okay in my mind, and like this is
Yeah, that's my thought
pretty
as
like
well.
outside of functional stuff, right? It's just like, okay, you turn on something extra on Windows. We've got some code in to make the calls. The only concern would be like, okay, we're doing these extra calls. Is there going to be overhead that people notice on other platforms? Or, I assume that actually the call is going to be pretty minimal since it's going to be if def'd out right now, right? And
Yeah,
um,
Yeah.
I never seen we releasing a feature to a specific environment, so that was my concern because I'm not sure what other folks will think about that. But considering we don't have an immediate solution for other environments, or at least at kernel or system level, I think we don't have other choice unless we start working on Node.js doing that integrity on its own code, but I think that's too much work, and it's very hard to cover all the cases, and that in fact will expose some vulnerability threats because if we don't implement that correctly, I can see a lot of CV being open for Node.js.
Yeah, I think like in this case, it's not like something where we're adding an API and that API won't run. Like
We are just
you'll be
adding
able
on
to
a
run
capability.
exactly the same code as you could in all environments. So it doesn't affect platform portability. It just adds something that says, hey, when you run in this particular environment, you're leveraging something in the OS. So like I don't personally, I don't think that's an issue, and I think that can be explained. The bigger, like one of the things that is like usually we add something as experimental. And
Mhm.
so really in this case, if there's no command line option, it really would be doc experimental only. So that'll have to, maybe
Yeah.
it should still
And
emit an
also,
experimental warning though.
we should flag it as Semver major just to be more cautious because even if it will be enabled if someone enable it on via system on Windows, for the ones that does it on a separate process for the same environment that runs Windows, it will be a breaking change, right? Considering that,
Um,
imagine that you are running a Node.js in a cluster with different process, and they run Node.js and Python on the same machine. And for the Python, imagine that there's the same system, and they use that catalog for the Python, and they expect it to fail only on Python. But if on a minor version it starts failing on Node.js as well, this can be considered a breaking change, right?
I think my understanding though is that there's this node specific key to turn it on, right? Like,
Correct.
so unless somebody actually went onto that machine and added this new
Okay.
key,
Oh, there's a
nothing
key
will
specific
happen.
for Node.js.
Exactly. So
Okay,
like,
okay.
so Sember Minor, I think in that case is reasonable. Have to sell that like like experimental
Mhm.
it just in the documents. I think though that like one thing that we do is like it should emit a warning, like an
Mhm.
experimental warning that says like we see that like it should probably check the key like the same way that it checks whether it's on or not. And if it's on, it should emit something saying you are using an experimental feature, blah, 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 right? Because that's one of the things we do to make it more likely people realize that, yeah, this is actually experimental.
Uh-huh.
Mhm.
Yeah.
So it wouldn't have a command line flag, but it would still emit that, hey, this is experimental. So like there's a standard way we do that.
Mhm.
And then certainly the documentation um, needs to make it clear to, back to your concern about making clear it's a seatbelt. And, if we can, like I think for the permission model, we've at least in some cases we've said like, yeah, we know it can be bypassed. That's not a vulnerability, right? It's more like a feature
Yeah,
request.
on the case of permission model, we specified or we limited the permission model usage to the file system API, Node.js file system, but not system file system. Like you can read files from different ways on Node.js. For instance, loading an extension from a third part dependency of Node.js. This is not covered by the permission model. The permission model only guarantees to the Node FFS API. So we limited ourselves there. And then once we improve that feature, we can expand and maybe
Yeah.
reach different levels.
I
I
think in
think
this
the
case,
way to
like,
think about this is that it's there's no such thing as malicious code, right? Once you've got
Mhm,
code running, this doesn't change Node's threat model. Once you've
mhm.
got code running, you've got code running. The goal of this feature is integrity protection of the code sitting in the file system.
Yeah.
And so if somebody does find a way to tamper with the content of a file that can get code running, that would be a thing we would intend to address, right? But if
And this
otherwise the code's running, then obviously they can tamper with the runtime and anything else.
yeah,
And if they find a way to temper that, possibly this won't to be a Node.js vulnerability, but a Windows one, right? Since we are using the Windows
correct.
calls.
I think
I
that
have to
if
drop.
somebody can get in terms of the integrity protection here, the idea is you've got an administrator with access to the file system. And the main point of this feature is like, how do you integrity protect sensitive server applications or sensitive client applications based on Node? If somebody can tamper with one of those files and then get code running, then that would be a thing. Like, and I don't mean tamper as in change the underlying NTFS data structures, that would be a different thing potentially. But it's more of if somebody got shell access and then they changed part of one of the files that managed to get code running, that would be an integrity violation that we would intend to address.
Okay. Um, One thing important that Michael mentioned on the chat is that we need to have that covered for ESM as well, of course. And I believe that we might need to talk with or built in because I expect that this test uh, won't fail on our current Windows suite because we don't flag the catalog or we don't uh, set up the catalog to make it fail, right? So I believe that we need to increase the test coverage on this specific feature, and also we need to get possibly to spin up a different machine that creates that setup to make the test fail for us. So this test we only run on Windows. We can do that. The second one is that I am seeing that we are calling the is allowed to execute file, and we need to make sure that it won't reduce the loading time for our tests.
Mhm.
So one thing is to let me see. Every time we check that, we go to the C++ level, right? Yes, we do.
Yeah, so that's something that I wanted to bring up too, and I think we can discuss it in the PR, the specific implementation of that. But yeah, if we are checking this every time, this is potentially a call on every file execution. So there might be a performance hit if there, and I'd be happy to like kind of get some performance tests set up and working on this so we can do comparisons to see if it's actually a significant performance hit. So I know we have a team internal at Microsoft that manages the Node CI/CD pipeline, and they have Windows build machine set up. I can
Yes.
work with them on if there is already a suite of performance tests that Node runs to uh, so we can gather metrics on that. Like that'd be amazing, and I'd love to basically have a bit more understanding of that and work with that.
Yeah, there is a loader suite of benchmark,
Okay.
but we also run some unofficial ones because it tends to be more realistic instead
Hmm.
of iterating every time we go and load it on big real systems and then we check the performance impact. But what I can say is that okay, we can that there's a flag to see if this is enabled or not, right? Before checking for every file.
Hmm.
We can basically on the permission model, if you look to the code, you see that there is a is permission enabled or permission dot is enabled, and basically
Hmm.
it's a constant that when it gets initialized, the value
Hmm.
doesn't change. So from the C++
Hmm.
level or from the JavaScript level, once the value is set, we never
Hmm.
change. So we only do system variable reference. So there is
Yeah.
no, it's very cheap. So I think
Okay.
this is the most important part for to do on the loader side, because
Okay.
once it's
And
disabled, it's basically no impact for Windows or Mac OS users.
okay,
So,
that's good to know because that's similar to how I've got it implemented at the moment in JavaScript. I save a global variable that is, hey,
Yep.
are we enforcing code integrity? That's checked in the loader before calling into the C++ library.
Yeah,
and
we can
one of
add
the
it to
things,
the, sorry, go ahead,
yeah,
Lee.
one of the things you had mentioned was you think it'd be a good idea to test this against like in the unit test passes to test this against a live system. So we've been doing this in on Windows for PowerShell and also VB script, W script, J script for many years. Um, that ended up introducing like that approach. We started with that. Ended up introducing a ton of like test flakiness in terms of
Mhm.
keeping machines up and all that kind of stuff. What we ended up finding was the most effective approach was to just have a kind of patch out the actual call to the OS to return the results we intend. And I think that's the path that Robert took. If you feel
Yeah.
strongly about testing this against an actual system, we're happy to go that way. It'll end up
Yeah.
pulling in a bunch of maintenance pain that I don't think you want, but um, just whatever how strong you feel about that.
Yeah, definitely we don't want to include more flaky tests on Windows. Uh, and if the Microsoft, the Windows team believes that this is uh, a valid approach, I would say realistic, but if that's a valid approach, that's what the Windows system is supposed to do. I'm fine to do that. Like, it seems feasible, and
Because yeah, like I think we want to get away from like so for sure manual testing of the actual feature actually works. But you know,
it will be
by the
flaky.
approach
I
that Robert
understand.
took of like just patching out one API call, we don't need to get into testing the actual Windows feature. There's the Windows feature team does that like to an inch of its life.
Okay. I'm looking to the code, and there is a flag, a global flag that already carried system code in force mode.
Mhm.
Uh, and I think we can, okay. Okay, so you already performed that check, the one that I
Mhm.
mentioned. So yeah, it shouldn't be hard to do,
Okay.
or it wouldn't have an impact, at least on Windows or Linux on OS X machines.
Mhm.
So I think the next step is more working hard on the docs. I
Yeah.
think it deserves a separate doc section. It can be
Okay.
called code integrity,
Yeah.
and we have a Windows section there.
Mhm.
And then once we have the documentation, I think it's way easier to expand it to the TSC and to the other people to review that. But I
Okay.
think we are going to the right direction if we all believe that it's okay to have a Windows specific feature.
Awesome. Glad to hear it. Okay, cool. So next steps for me are I'll elaborate a bit more in the documentation. I'll look at the permissions model for kind of share this similar language to express that, hey, this is a seatbelt feature and this is not a hard security boundary for Node.
Mm-hmm.
And I'll probably add this document, or we can discuss it in the PR, but I'll just put this kind of near the permissions model documentation and see where it goes from there.
Yeah, and if we can increase the test coverage, also would be amazing. Regardless, if we are testing it, trusting in the system or patching it.
Okay.
Um, I think that's looks great. Possibly we'll have a lot of reviews and comments because we have some Node.js specific checks. So,
Yeah.
but don't worry about that.
Mhm.
And I will review it properly, like on the code, line by
Yeah.
line, once we have the documentation. But it looks great.
Awesome. Glad to hear it. Well, appreciate your help working through this.
Okay, amazing. So do you have anything else or any other question about the flow of this request?
Um, Not at the moment. Not for me. Lee, do you have anything?
I guess one other thing, sort of how Michael mentioned of like, hey, we need to make sure that EJS loader is
I think
enlightened.
he is
Uh,
mentioned ESM, I guess. I think
DSM?
yeah, the
Yeah.
ESM.
Yeah,
Okay,
that sounds. I think that's something that I only wrote this for the comment. What is it? CJ, the common
Homo.js,
JavaScript
yeah.
there, and need to. I I guess there's a second path that code JavaScript code can be executed by that I missed. So
Yeah,
okay.
and actually a third one that's now TypeScript. So yeah, long journey. We can, if we prefer, we can disable it for TypeScript and mention in the docs because For the TypeScript is now highly experimental. So if we just focus on ESM and Common.js, that's fine.
Okay, I think eventually, long term, we'd like to have complete coverage with this. But as for getting our foot in the door with this PR, just getting something basic, just getting something just as a good baseline, we can ignore TypeScript if it seems a bit too messy.
Okay, so I will have.
And the other thing I wanted to ask was, so Robert went and addressed this, made sure that there was parity for everything that was using the integrity system. So everything in the past that was integrity protected now should be protected by this feature. If there are other kind of inputs of code to Node.js, where like it might be loading stuff that is code-like from the file system at some point, if you or from user input, like environment variables or command line flags or whatever. If there are some folks that can help like think through like any that might be missing, that might have missed the initial integrity pass as well. Please, like one of the examples that Robert's I think is in the PR is making sure that like the eval command line flag is disabled because you can't protect that.
Okay. I think the best thing to answer that is the loaders one once we tag them. I think if as far as I know, all the loading mechanism for any JavaScript file exists on the ESM and the CommonJS loader. So regardless if you are trying to read from file system and trying to evolve that, it might go to the files to the no, I think if you read from the file system API, let's say that read file sync, and you try to evolve that string, it basically bypass that, I guess. So I think we might want to add a check to every file system call, and that would be bad, I guess.
So specifically, if they're calling eval within their JavaScript code, I think we would just consider that an application vulnerability and not a Node.js vulnerability, because it's hard to protect against a developer calling eval on any.
Yeah.
They could download a string from the web and eval it, and like that's an application problem, not a Node.js problem.
So we need to specify that the code integrity is restricted to the import and require calls only.
Okay.
Which is the module
Or I guess
loading.
Node.js runtime things, right? Like if we get too fine-tuned on the language, like for example, if Node ends up having a thing where, you know, application config dictionaries are stored and then eval directly, that would be a Node.js thing that we would intend to address, even though it's not, you know, directly TypeScript or the application JS.
Yeah, my only concern is that if we don't specify that we are restricted or limited by the require and import, someone in the future might create a different function call that will require and bypass that even in a new feature. And if we restrict to import and require, we won't get that HackerRun report, but we can also add support and improve the documentation later about that. I think it will be more easy to manage or to maintain than on the documentation expressing that we are adding code integrity for everything, but Node.js runtime specifics. But you know, like you can also mention in the docs, and we discussed there, and I'm happy to change my mind. I will have to comment on the request that we have discussed, and the next steps are improve documentation and tests, and then we can go to a proper review to the code.
Cool. Sounds great. Thank you so much for assisting with this entire process.
No worries. I'm happy to see this thing, and I'm happy to also if you have any insights about someone working on that on Linux, on macOS, I'm happy to help as well, because this is something that I would like to see.
Awesome. Yeah, sounds good. Cool. Well, thank you for your time this morning.
Okay, thank you, Lee. Thank you, Robert.
Taylor,
And
thanks.
that's
See you
the
later.
yeah, that's the end of our agenda. And see you.